probably be starting lecture off with this example, but I thought I would show a solution to this problem because it kind of relates to a daily quiz problem if you happen to be keeping up with the daily quizzes. But we'll start Wednesday's class off with this example here. But I just figure why not show this problem and take a couple minutes if you want to watch this video before Wednesday's class. If we want to convert 225 liters to cubic meters, there is a conversion factor we gave in the notes. Like we had said previously that there's 1,000 liters is a cubic meter, and so you might be able to use this conversion factor if you know it by heart. But the one conversion factor that lets us make this conversion here is this one here, that a milliliter is exactly 1 cubic centimeter. So this is a pretty straightforward conversion factor that hopefully, if we don't know it, we will appreciate that this is an exact conversion between the milliliter scale and the cubic centimeter scale. And so if I said, okay, this is the only conversion factor we know, we should be able to make this conversion here. So our number of cubic meters, what we're looking for, start with their 225 liters. Let's do a conversion over to milliliters so we can try to use this conversion factor. So 1 liter is 1,000 milliliters, exactly, of course. And then we use our milliliter to cubic centimeter. And then the centimeter conversion, we got 100 centimeters in a meter, but we have to cube the entire conversion. So if you imagine having a cubic meter box where it's 1 meter by 1 meter by 1 meter, imagine that these are 100 centimeters each. So 1 meter by 1 meter by 1 meter would be equal to 100 centimeters, that's a meter, by 100 centimeters by 100 centimeters. So hopefully what you can see is that 1 cubic meter is equal to 100 centimeters, but where we cube that dimension, or that conversion factor. So cube the 100, cube the centimeters. So using that conversion factor here, we're going to cube the 100, cube the centimeter, and then we can convert 225 liters times 1,000, and then divide by 100 cubed, and I get 0.225 cubic meters. Now, of course, if you knew this conversion here and you had that memorized, or you knew what it was, usually we don't give this one on task if you need it, but if you just use this conversion factor, of course, you're just dividing 225 by 1,000, coming up with the same answer. So then here's some extra sig fig problems that we'll post here. So let's look at these problems here. 25.56 minus 8.4. Addition and subtraction problems are much easier if we line them up with the decimal point as so. Do our arithmetic. 17.16. And I'm going to round this to 17.2. Four sig figs times 3 sig figs. The number of sig figs should be 3, so let's do the math. 25.65 times 4.34. We're going to round this to 3 sig figs, so that's 111. And then our third problem, we're going to do this rule first. Looks like that's going to be 4 sig figs. 14.5 plus 94.3 is 108.8. Where all those 4 digits are significant. And then divide by 4 sig figs, so we're going to keep all 4. So that'll be 2.443. Just rounding accordingly. And then a few additional ones. Add 25 here. So 125 grams. Second problem, 10.0 divided by 5.0. Do this in a calculator, obviously. I mean, you don't need to put in a calculator. It's 2.00. So So we want to pick up those extra zeros because we should have 3 sig figs in our result. And we match that up here. This is actually, is that the same problem from before? It's pretty similar. Maybe I misread it before. Because I think I did 44.25. Maybe I reread it on the previous slide. But 25.8 plus 94.5. Oh, this is a different problem, but it's the same basic approach. 120.3 grams, 14.25 divided into it gives us a density of 8.44. One more digit, 2 grams per ml. And then let's see this conversion here, inches to centimeters. Now this is only done, 25.83 is our lab measurement. Our centimeter conversion is at 1 inch, is 2.54 centimeters, but this is exact. You know, most conversion factors should either be very precise or exactly defined, and this is the case where it's exactly defined. 2.54 isn't rounded from some more longer conversion factor. So when I multiply by 2.54, I'm going to keep 4 sig figs, 65.61. Now the reasoning here is I have 4 sig figs times an infinite number of sig figs. Now some people look at this and say, well, why don't you round to 3? And I say it's not an inexact quantity. This is an exact quantity. We round based off the inexact quantities. This is the value subject to the inexact quantity sig fig rules because it's an ordinary lab measurement, not the exact conversion factor. Now another thing I like to say is if you think we should round to 3 because of 2.54, then why don't we round to 1 because of the 1? And the answer is, well, 1 inch is exact. I mean, that's the equality. So let's not get mixed up on rounding conversion factors. The same thing, like if you're going to round this to 3, be careful then not to round like 1,000 milliliters to liter. If this isn't a conversion, that's an infinite number of sig figs too, because that's an exact conversion. There's exactly 1,000 milliliters in a liter. We're not rounding that to 1 sig fig or anything along those lines. Okay, so just a couple more sig fig problems. We'll see a few more sig fig problems in the chapter 2 notes. And there's a bunch on the daily quizzes if you need more practice. And of course, there'll be a few on the pre-lecture assignments. All right, guys, thanks for the attention.